Today we were talking about the saponification value. Saponification value. Now saponification value is saponification value. The significance it tells you the amount of sodium hydroxide or potassium hydroxide that is needed to make soap can be determined by this value. Okay, now the definition. What is the saponification value? It is the number of milligrams of potassium hydroxide required to saponify 1 gram of oil or fat. So this is what is meant by saponification value. Number of milligrams of potassium hydroxide needed to saponify 1 gram of an oil or fat. Okay. So you can make a calculation based on this, based on the chemical equation of saponification. Now, saponification is actually esterification, hydrolysis of an ester. Which ester? Triglyceride ester. See here, this is your ester, oil or fat. C17H35. Suppose you have a stearic acid ester. Your soap is, your oil is a stearic acid ester. Assume it is a stearic acid ester, C17H35. Again here also O, C11O, C17H35. Suppose this is the ester. Now, this will react with 3 moles of potassium hydroxide, and that will give 1 mole of glycerol will be free, CH2OH, and CH2OH will be free. Plus what? Plus 3 moles of oh my god, what is wrong with my connection? 3 moles of C17H35 COO minus K plus So this is the salt. This is what is called soap. This is potassium salt. Okay. Now, let's look at the molecular mass of this and make a calculation. Suppose you calculate the molecular mass of this, you will find this is 890. If you calculate the total molecular mass, it is going to be 890. Then this, so 890 gram will require 3 into molar mass of potassium hydroxide is 56. 3 into 56 equals 168 grams of potassium hydroxide. 168 grams of potassium hydroxide. Now this is the amount required. Now the question is 1 gram of oil, 1 gram will require how many grams? That you convert into milligrams. That will give what is saponification value. Okay. So let us do the calculation. 890 requires 168 milligrams. So 1 gram will require 168 upon 890 gram. Okay, equals 0.18876 gram. Okay, 188.76 gram. This equals 188.76 milligrams. .76 milligrams. So, saponification value for stearate, tri-stearine. This is tri-stearine. Is 188.76. Okay. Now, that means, what is this 890? 890 is the molar mass. 890 is the molar mass of your oil, assuming it is only stearic acid. Assuming it is only stearic acid. Now, but in practical terms, what happens is, you don't know what is the molecular weight of your oil because you don't know the actual composition of your oil. You have no idea about the actual composition of the oil. It can be stearic acid, oleic acid, or palmitic acid, or a mixture of all these three. That is the reason why you have to find the saponification value every time. That is why you have to find the saponification value every time for each sample of the oil. It is not, you cannot calculate it directly. Calculation is based on this assumption. If you know the molecular weight, you can calculate it. That is why you have to do the experiment. Now, so what we do is, and of course, calculation, suppose you do an experiment, a titration to find out the saponification value. Say, for example, you take uh, about 1 gram of an oil. See, what you do is take 1 gram of an oil, add water and ethanol. Water plus ethanol. Ethanol is added to make it soluble in water. Ethanol is added to make it soluble in water. Okay. Now, into this you add known amount of potassium hydroxide solution or standard potassium hydroxide solution. Okay. Standard potassium hydroxide solution means the concentration should be known to you. Add into this. Now you keep a reflex condenser here. I hope you know what is a reflex condenser. This is a reflex condenser. I'll show you. See this. A Liebig's condenser it is called. What happens now? You have to pour water, enter the water here, and water will go out from there. Okay, the outer tube will be filled with water. You must have studied this before. I have already told in the class. The outer tube will be circulating water so that the inner tube will be condensing the liquid which is boiled and it will fall back. This process is known as reflex. Okay, reflex. Boiling up, condensing down. Now you reflex it for about 1 hour. Okay, so I'll repeat what we have done. Taken a flask, RB flask, took about 1 gram of oil, add water plus ethanol, add a definite volume of standard potassium hydroxide, reflex for 1 hour, then what will you do? Cool it, titrate the solution, titrate the whole mixture, with standard HCl. Standard HCl. Okay. What you will get? You will get the amount of potassium hydroxide inside this reaction mixture. So we will get amount of potassium hydroxide in the flask. Okay, so we have found the amount. But what is this potassium hydroxide? This is the potassium hydroxide which remain unreacted, which remain unreacted, or which we have added in excess. Okay, this is the potassium hydroxide which we have added in excess. So whatever potassium hydroxide which is reacted with the oil, that we can find by knowing the initial amount of potassium hydroxide which we have taken. Okay. For that purpose, what we do? What should we do for that? To find the initial amount of potassium hydroxide, what we do is take the same amount of potassium hydroxide we have added into the flask. Okay. Say 40, suppose we have added 40 ml of potassium hydroxide here. Take 40 ml of potassium hydroxide, same solution, KOH, and titrate it with HCl. Titrate with HCl. This will give the total amount of potassium hydroxide which we have poured inside. Initial potassium hydroxide. Initial value of potassium hydroxide. And here we have got the amount of potassium hydroxide unreacted. So, amount of KOH reacted with oil equals what? Initial amount minus unreacted. Okay, so you will get now the amount of potassium hydroxide reacted. Okay, that value will give you the saponification number. You convert that in grams into, since you have taken 1 gram, you divide it by the amount of substance you have taken and find out how much 1 gram will require. If you have taken exactly 1 gram of the oil, okay, your answer is it's a saponification value if you express it in milligrams. Okay, if you express it in milligrams and if you started with 1 gram of oil, exactly 1 gram, that your answer, the titer value, the amount of potassium hydroxide which you have calculated from this titer value will be the saponification value. So for each batch of the making the soap, the industry will do the saponification test. Then only they will add the sodium hydroxide or potassium hydroxide to manufacture the soap needed in the particular batch. Okay. Now, whether a high saponification value or a low saponification value is favorable for an oil, a high sap value is demanded. High sap value means more ester. More amount of ester is present. High sap value means more amount of ester is present. Okay. And that will give you more amount of soap. More soap. So this is saponification value. The next one is iodine value. I'll wipe out the board first now. Okay. I'll wipe out the board. I hope you have already written whatever is required. Just 1 second. Next one is iodine value. Iodine value. Now, iodine value means, yeah, I'll give the definition first. Then I'll tell you what stuff it is. It is the amount number of grams of iodine. Number of grams of iodine. That is added to 100 grams of, that is reacting with 100 grams of remember it is 100 grams of oil or fat. Okay. So that is, what is that reaction? How does the oil and fat react with iodine? If your oil is, of course, your oil is definitely containing double bond. Okay, basic organic chemistry, what we have done, we have studied this addition reaction. Addition reaction. What is addition reaction? Addition of across a double bond, you can add halogens. Which halogen? You can add Cl2, Br2, I2. Okay. These three you can add across a double bond. Now, if you add, the double bond will be converted into single bond, I. Now you can do this with certain reagents. And you can calculate how many grams of iodine is added with a particular amount of, let's say 100 grams of the oil which you have taken. So this gives a measure of, it gives a measure of the unsaturation. Measure of unsaturation in the oil or fat. That is how much of double bond is present. That is meant by unsaturation. How many or how much of contribution of double bond is present. Now remember, this is not having much again. Okay, got it. One second. Let me take the board again. Where is my board? Yeah. So, iodine value gives you an idea about the extent of unsaturation. Soap manufacturer will not be having any interest in this. Okay, they will not worry about the iodine value, but iodine value is important for I think I'm having an unstable internet connection today, it seems. My signals are very weak. Let me see. It seems to be pretty weak today. Anyway. My internet connection is very, very bad. I think okay. So this is used for the bad connection. So iodine value, it is used by the vanaspati manufacturers. Now let me tell you, let us talk a little about manufacture of vanaspati. Conversion of oil into fat. Is done by, I told you, done by hydrogenation. H2 addition. To oil. To oil. Because oil contains double bonded oleic acid component. You saturate it, it will become stearic acid or palmitic acid mixture. And that will make the melting point high. Okay. So unsaturation of the double bond will increase the melting point. And that way oil becomes fat. Now why do you do that? Why do you do it? Why is it done? Fats are more stable than oils. Double bond will lead to rancidity. Rancidity means, you must be knowing what is rancidity. The bad taste. Of the oil when kept for a long time. Okay, this is what is called rancidity. Okay, what we call in Malayalam it is karal. The oil will have a bad smell as well as taste. This is due to oxidation. Due to oxidation of double bonds. With atmospheric oxygen in presence of water. What? Moisture. So in order to avoid this and convert it into a solid, people use this. People add hydrogen. Now the question is, why do they want this? Why do they want the iodine value, extent of unsaturation? Why it is required? Why is it required? The idea is each company will have, you must have seen in the market, Dalda is quite hard. Dalda you must have seen. This is a brand name of, I think, Hindustan Liver. It is, it's almost a solid. Then you have some other in the market. Like what is the market? I don't know whether you people are. What we generally see here is Liberty. Some brand is there locally. Liberty. It is almost a liquid. Not completely liquid, nearly liquid, semi-solid. So each company will be having their own specification. Each company decides their own specification for the Vanaspati. So what they do is, they do the hydrogenation, they continue with the hydrogenation till the required nature is obtained. Till required nature of product is obtained. Till that time, they'll continue hydrogenation. So what is the required nature? That required nature they can find from the melting point. Or by taking the iodine value. Melting point will be very rough value, but iodine value is the best. Okay, so they find the iodine value and decide how much hydrogenation is to be done on the sample. Okay, now there are two methods for finding out iodine value. There are two methods. Number one, Hubble's method. Hubble's method. Okay. Now, in this method, we use Hubble's reagent. The oil or fat reacted with iodine solution in presence of mercury chloride, iodine and mercury chloride. So iodine plus mercury chloride plus I2 gives you HgCl plus ICl, iodine monochloride. Okay. And this iodine monochloride is used to saturate the double bond. Okay. In the second method, which is called Vigi's method, now oil or fat is directly reacted with